Hey guys, this video is about forces. Alright, so I'll be introducing forces in this video. Okay, talk about balanced forces and unbalanced forces, and talk about contact forces and non-contact forces. Alright, first, force. Force is a push or pull, right? So when you push or pull an object, you are exerting a force on the object. Okay, a force can do quite a number of things. It can start or stop an object. It can change the speed, make it go faster, make it go slower. Or so these two basically change speed. Okay. It can also change the direction, or it can change the shape. Okay. So a force can do quite a number of things, right? So when an object, okay, exhibits any of the behavior here, okay, a force must be present. Okay, it needs we need a force to stop an object, okay, or to cause it to start moving. If I don't exert a force, if there's no force acting on the object will not stop. Okay, or the speed will also remain the same. Okay. Okay. So on every object, right, I can have multiple forces acting on it at the same time. Okay. So depending on the forces, what direction they act on and how big are the forces, right? The forces may be considered to be balanced or unbalanced. Okay. So we are talking about balanced forces on a body, or the forces on a body are balanced. Okay, so what do we mean by the forces on a body are balanced? The forces cancel each other out completely in a balanced force scenario. Okay, so that means left equals to right, right, up equals to down. Okay, the forces are in opposite direction and they are equal. So they are able to cancel out each other. Okay, in this case, F1 and F2 are opposite and equal, so balanced forces. The object is the forces on the object is balanced. Okay, so same thing for this car. So the engine, the amount of force the engine puts forward and the amount of air resistance the car experiences is the same. And then the forces on the car is balanced. Okay. So unbalanced forces, okay, opposite of balanced forces, we have the forces, they cannot cancel each other, 8 and 5. Okay, when they don't cancel out each other, right? When they don't cancel out each other, I will have a resultant force. So my resultant force or net force in this case is 8 minus 5, 3 newtons. And it will be in the direction of the stronger one. So 8 newtons is the stronger one. So to the right. Okay, if both are in the same direction, they will add up. So here my net force is 12 plus 4, 16 newtons. And since both are to the right, obviously the resultant will be to the right as well. Okay. So if the forces are not parallel to each other, right, they cannot cancel each other. If they cannot cancel each other, the resultant will be calculated by another method. We will touch on the scale drawing method, okay, in another video. Okay. Next, contact forces and non-contact forces. Okay, as the name suggests, contact forces are forces when touching, okay, exert a force, which is almost everything. Okay, you have to touch something to exert a force. Non-contact force can act from a distance. Okay, so when I say non-contact force can act from a distance, you probably think of manex straight away. Okay, the magnetic force. Okay, other than magnetic force, we have electrostatic force, we have gravitational force. These are the few forces that you will need to know, okay, roughly. Okay, electrostatic force is when the, the electric charge attract each other. Magnetic force is when magnets attract each other. Gravitational force is when masses attract each other. Okay, and Earth is a very big mass, it attracts us. Okay, so other than these three, right, we have the strong nuclear force and the weak nuclear force, which you don't even need to know that they exist. Okay, uh, yeah. Okay, other than all these, right, okay, all other forces that you will ever encounter, all of them are contact forces. Okay, this means what? This means that for mechanics questions, right, okay, and forces questions, most of the time, when you are asked to draw the forces on an object, you will only need gravitational force. Okay, now I dare say 100% of the time you will not see electrostatic force or magnetic force in that question that they ask you to draw forces. Okay, so gravitational force is the only force that you need to concern yourself with. Okay, example, let's say that I have an object that is resting on a slope. Okay, what is my focus? My focus is this piece of box. Okay, and the question want me to draw all the forces on the object. Always start with weight first, because he is the only non-contact force that you need to concern yourself with. Okay, just as a double check, is there any magnet? Is there any charges around? No, don't have. Okay, so no electrostatic force, no magnetic force. Okay, now I'm done with the non-contact forces already. Let me ask myself, the rest must be contact forces. So what is my box in contact with? It is in contact with the ram. The ram will exert a force called the normal contact force. Okay, this normal contact force prevents the box from going into the ram. Okay, and then on the surface between the box and the ram exists friction or frictional force. Okay, is there anything that the box is touching? No, nothing already. So I'm done with my forces diagram. Okay, let's say that I have a ceiling. Okay, I have a hook, two of them in fact, and then I got a string and then hang a ball. Okay, now question is, my ball is my focus. I want to draw all the forces on the ball. Okay, all the forces on the ball. So first, draw weight. Okay, weight must be vertically downwards. Okay, next, is there any charges? Is there any magnets? No, don't have. Okay, so no electrostatic, no magnetic force. Next, I'm done with non-contact forces already. I'm looking out for contact forces. What is my ball in contact with? It is in contact with the strings. Okay, so the strings will exert this force called tension. Okay, and then is there anything my ball is touching? No more already, and I am done. The question Next is this. How about the force here? The string is also pulling the hooks, right? The string is also pulling the hook, right? How about the wall? The wall is pulling up the wall is pulling out the hooks, or the hook is pulling down also, right? You are all correct. But what is my focus here? My focus is the ball. Is the hook touching the ball? No. So the hook is not touching the ball. The hook cannot exert a force on the ball. Okay. Same thing with the ceiling. The ceiling is not touching the ball. The ceiling cannot exert a force on the ball. Okay. Because other than weight, all other forces are contact forces. They must touch to exert the force. Okay. And that's it for the balanced force, unbalanced forces, contact forces, and non-contact forces.